Hello guys, I hope all of you will be fine. So today we are going to discuss another very important topic, and that is the calculation of a probability mass function, which is also called the PMF. Okay, so what is this? So to illustrate the concept here, we are having a numerical example here, and with the help of this example we will try to convey the concept of probability mass function. Okay, so the question here is that let capital X or X be the number of heads in 3 independent tosses of a coin. Okay, so a coin has been tossed 3 times sequentially. So what do we have to do? We have to find the PMF of X. So X is the random variable. What is X here? So X is the random variable here. Okay, and this random variable is the number of heads in 3 sequential coin tosses. Okay, coin tosses. So this is basically a random variable, and here we have to find the PMF of it. So what is basically a PMF? That is the plot of the values of the random variable with respect to the probability of each random variable, okay, or each value. So what do we have to do? We have to find the probabilities here. So the probability of X is equal to what here? So how many items would I have here? So the items will I have here would be probability that heads is equal to 0. Okay, similarly the probability of heads equal to 1. Okay, the probability that heads is equal to 2, and the probability that heads is equal to 3. Okay, so we have to find out the values of each of these probabilities, and as the coin we are tossing here is supposed to be a fair coin, so therefore the probability of heads is equal to the probability of a tail, and that is 1/2. Okay, so we have to find out the probability that heads is equal to 0. So here how many items would I have here? So let me find out here. So the probability of heads equal to 0 will be the items that I have to find out the probability of all the items. Let me give the items here. So when the probability that heads is equal to 0, that would be the tail, because in all of 3 tosses what would I have? I have 3 tails, and here as the 3 items here are independent of each other, so therefore their probabilities will be multiplied together. Okay, we can see that here this is 1/2 multiplied by 1/2 multiplied by 1/2, and this is because the probability of tail multiplied by probability of tail multiplied by the probability of tail. Okay, why is this? Because these are the events which are independent. Okay, so these are the independent events, so therefore their probabilities are multiplied together, and at the end what I will get here I will get 1/8. Okay, which is the probability of heads equal to 0. Okay, for finding the probability of heads equal to 1, which items would it be? So let me write the items here. So when heads is 1, so the items here would be either the first toss give me heads, this other twos will give me tails. Okay, the second will give me heads, while the other two are giving me, the first and third one is giving me tails. Similarly the third item is here, and that is what? That is here, and that would be the tail, heads. Okay, so these are basically the three items, and we can see that these are all together. Either we will get this one or this one or this one. Okay, so let me see that this is for it. So let me move down somehow. Okay, so here, in order to find them out, what I have to do, I have to find out the probability of heads, tail, okay, or the probability of tail, heads, tail, or the probability of tail, heads. Okay, you can see that why I am adding them together, because of the or condition here. Either this will happen, or this will happen, or this will happen. So therefore I am using here addition. If this was the AND condition, or simultaneously each of them can occur, so I will have used here the multiplication, which is just like here, that here heads, tail, tail. If heads is occurring with it, and tail and tail, another two tails will occur, and therefore what I have to do here, each of the item here is independent. So what I have to do here, it will be probability of heads, probability of tail, and probability of tail. Okay, similarly I have to add here because of OR condition. So here I will have probability of tail, probability of heads, and probability of tail as well, again and again, or probability of tail, probability of tail, and again probability of heads. Sorry, probability of tail multiplied by probability of tail and probability of heads as well. This is the correct form, and we can see that all the items here are independent. So these three are independent. Here we can see that these three are independent, these three are independent, these three are independent. Okay, so what I have to do, let me move down somehow. Okay, so let me write their values. Okay. So writing their values, what I have to do, the probability of heads and probability of tails, this is given here, and that is 1 by 2. So therefore 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2, that would be 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2, plus similarly here 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2, and here as well 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2 here as well. So what I would get here, it would be 1 by 8 plus 1 by 8 plus 1 by 8, okay, which will ultimately give me 3 by 8. Okay, so this is what this was for the heads 0, and this is the probability of heads equal to 1. Okay, so we have found out the two values. The first one is heads equal to 0, the second one heads equal to 1, the third one is the heads 2 and heads 3. So let me find them out as well, and for it let me move down. Okay, so here what I have to find out, I have to find here the probability that heads is 2, and what are those events. So let me write down here. So those events are either heads, tail, okay, or heads, tail, heads, okay, or tail, heads. Okay, so these are the three events where the two heads can occur. So let me find out their probabilities, and using the same scenario whatever we have used here. So here I will have the probability of heads, tail, plus probability of heads, tail, heads, plus the probability of tail, heads. Okay, so at the end, by using the same probabilities as we have done here, so let me point them out here as well. So we have separated them out here. So using the same scenario here, and at the end what I will get, 1 by 8 plus 1 by 8 plus 1 by 8. Okay, so what are these? This is for this one, it is for this one, and this one is for this one, and adding them together, what I will get? I will get here 3 by 8. So what is this? This is for heads equal to 2. Okay, so this is for the number of probability of the heads equal to 2. Similarly for the last part here, and that part is what? In that part I have to find out the probability of heads equal to 3. Okay, so the probability that I will get 3 heads in 3 tosses, so that would be the probability that I have to get the heads in 3 tosses. Okay, so here in order to find the probability of it, what I have to do, I have to use probability of heads multiplied by probability of heads and multiplied by probability of heads. Okay, so writing their probabilities, I will get 1 by 2, 1 by 2, 1 by 2. So here I will get 1 by 8, and this is for what? This is for the heads equal to 3. Okay, so this is for heads equal to 3. Okay, so here we have found out different values. So let me write down here. We have found the value of the probability of heads equal to 0. The value of it is what? That is 1 by 8. Okay, the probability that heads is equal to 1, its probability is 3 by 8. Okay, let me move down somehow. The probability of heads equal to 2 is also 3 by 8, and the probability of heads equal to 3, that is what? That is 1 by 8. Okay, so this is what we have found out, and we can see that this is the these are basically the numerical values which we have found out for the random variables which are here, the number of heads. Okay, so these are basically what? These 0 1 2 3 0 1 2 3, these are the values of a random variable, while this 1 by 8, 3 by 8, 3 by 8, 1 by 8, these are the probabilities of these random variables. Okay, so one way is to describe them numerically, the other way is to plot them on the graph. So let me have a graph here. Okay, so let me draw that graph by using this color. So when I will have a graph, so let me have a plot here. Okay, so here this is the random variable or x here, because x is the number of heads in 3 tosses, and this is the probability of this x. Okay, so here the probability will be shown. Okay, so how many items could I have here? So let me plot them. So here this will be either I can have 0 heads, or 1 head, or 2 head, or 3 heads. Okay, so on the basis of it I have to assign them different probabilities. Okay, so the first value here would be what? So let me plot it by using this color. The first value is 1 by 8, so let me write it here. So this would be here, and this, let me call it what? This is 1 by 8. Okay, for the second one, let me have it 3 by 8. So for heads equal to 1, what I would have? I would have here this one. So I can plot it, and here this is what? This is, let me call it 3 by 8. Okay, for the number of heads equal to 2, the probability of it is again 3 by 8. Okay, so let me plot it here as well. So this is again 3 by 8, the value of it is 3 by 8, and for the probability of heads equal to 3, this is what, this is 1 by 8. So let me plot it here. So this is also 1 by 8, which is here. Okay, so this is 1 by 8, this is 3 by 8, this is 3 by 8 as well. Okay, so we can see that what is this graphical representation basically shows me what this is called the probability mass function, or also called PMF. Okay, so this is the probability mass function, or also called the PMF, and that is the probability mass function for the number of heads in 3 tosses. Okay, so in this example what we have seen that how to plot the probability mass function for different items which are given here, and this is what, this is the probability mass function for a question which is given, in which let x be the number of heads in 3 independent tosses of a coin. So I had to find out the PMF of x. So this is the overall procedure by following which I have found out the PMF of our statement. Okay, so I think all the steps are covered here in this question are now understandable to you. All the steps and all the ambiguities are clear now. Today the topic which I am going to cover is the expected value of a random variable. How can you find out the expected value or average value of a random variable which is given to us in the form of a PMF plot? Okay, so previously we have solved a question, so let me have a look over it. So this was what, this was the PMF plot or probability mass function plot for our random variable, in which the random variable is the number of heads in the 3 sequential coin tosses. Okay, so for the same problem what we are going to do, we have to find out the expected value. Okay, so how can we find out the expected value, which is one of the very important measure of the characteristic of a random variable or probability mass function in statistics or probability and random variables. Okay, so let us find it out. So expected value is represented by E capital X. Okay, what is X? That is basically a random variable. And how can we find it out? There are various methods for it. First is that in statistics what we can do here is that we can add all the values. Okay, all the values have to be added together, and these are divided over the total number of elements in that set. Okay, but here what we are given in the PMF, we are not given these two things, so we cannot apply it here. Okay, so instead of it, what I have to do, I have to apply some other formula. Okay, so let me use the expected value, and for it what I can do, I have to write the value of the random variable x and multiply it with all the values or the probabilities of all of it. So by using it, what we can do, we can find out the probability or the expected value of that probability. And what is this? This is the formula for our today's question. Okay, so did I have the values of the random variables? Yes, we had them. Okay, and did we have their probabilities? Okay, yes, we had them here as well. So let me move to the previous question here as well. We can very easily see here that here we have these 0 1 2 3. Okay, so what are these things? These are the x, which are the values of a random variable x. Okay, so these x are the subset of x. Okay, similarly, what are these 1 by 8, 3 by 8 and all of them? these are the values of the probability of x. Okay, so we can write them in our formula which we have mentioned earlier and find out the expected value. Okay, so let me find the values here. So in order to find the values, what we can do, let me write their values. Okay, so in order to find the expected value of the first element here, what I have to do, the first element here is 0 and I have to write the probability of heads equal to 0. Okay, I have to add with it 1 and with that I have to multiply the probability that heads equal to 1, similarly 2, and with that I have to multiply probability of heads equal to 2 plus 3 multiplied by probability that the number of heads is equal to 3. Okay, so we have these values, this is 0 and the probability of 0 is 1 by 8, the number of heads is equal to 1, this is 1 by 8, similarly 1, and the probability that number of heads is 1 is 3 by 8. Similarly the 2 and the probability that the number of heads is equal to 2 is again 3 by 8, and 3 multiplied by the number of heads is equal to 3 is 1 by 8. Okay, so we can confirm it from our previous question as well, that here we can see that the probability that heads is equal to 0, the probability of it is 1 by 8. Similarly the other probabilities are also given in this table. Okay, we can see that these are given in the form of this table. Okay, so let me proceed to our question. Okay, so here in order to find the question, what would we have here? 0 plus 3 by 8 plus 6 by 8 plus 3 by 8. Okay, so adding them, what I will get? I will get 3 3 6 6, so it will be 12 by 8, or I can use them by 3 by 2, or at the end we will get the expected value equal to what? That is 1.5. Okay, so what is this? This is the solution or expected value of our previous question, and I hope all the steps covered here are understandable now. So in previous lectures we have talked about the expected value and also the conceptual overview of the standard deviation and variance. Today we are going to talk about three more very important conceptual quantities, and these are the mean, median and mode. Okay, and what are the need of calculating the mean, median and mode of a data. Okay, so suppose we have a data and in that data we have certain points. Okay, so we have, let me have 5 4 1 3 8 2 1 4 and 3. Okay, so here we have this data, and on the basis of this data we have to find the statistical analysis of this data, and in order to analyze it statistically we have three quantities which are mean, median and mode. Okay, so what is basically the mean? Okay, in order to find out the mean, let me write here the mean. Okay, so what is mean? In order to find the mean, what do I have to do? I will do what? I will add all the quantities which are here. So the quantities I have are 5 plus 4 plus 1 plus 3 plus 8 2 4 plus 3. Okay, so these are all the numbers which we have here, and in order to find the mean of it, what I have to do, I have to add them together, and at the end after adding them I have to divide it over the total number of the data items or data samples which I have. So how many number of items do I have? So 1 2 3 4 5 6 7 8 9. So I have 9 numbers and I have to divide it over 9. Okay, so let me add them. So 5 plus 4 plus 1 is 10, 10 plus 3 is 13, plus 8 is 21, 21 23 24, 24 plus 4 is 28, and 3 is 31. So 31 divided by 9, and dividing it over 39, what I will get, so 31 divided by 9, so 9 3 27, okay, 4 will be here, and here I will get 9 4 36, okay, and 4 again, so again and again, so I will have here 3.445, okay, so I have 3.45, so this is what, this is called the mean or expected value of the data which I have here, okay. So this is the expected value of the overall samples which I have. So suppose this is what, this is the quantity that a certain number of the rice has been consumed in 9 weeks. So in order to find the expected value, what I have to do, this is the expected value, okay. We can also demonstrate it by using the graph like this one. So let me have these 9 numbers, so these are 1 2 3 4 5 6 7 8 9, okay, and the data points I have are the 5 4 1, okay, 3 8 2, this is 2, also 1, okay, this is 4, and the last one is 3 here, okay. So these are all the numbers which are basically distributed here, okay. So this is the distribution of the numbers which I have here, okay. So in order to find the average of them, which is 3.45, and to write it here, what I will have here, so let me have this 3, so 3.45 is almost here. So this is what, this is the expected value of the numbers which I will have, which will remain constant here, and this is the constant quantity which will remain constant throughout the weeks, okay. So this is the average value or the mean value of the rice consumed in a certain area in certain weeks, okay. So this is the mean value of a number. Similarly, what if I want to find out the median? So what is basically the median? Median is basically the mid value, okay. So what are the numbers I have here? So this is the data and these are the numbers, and in order to find the median, what I have to do, let me calculate the median of it here. So in order to calculate the median of it, first of all I have to sort it. So in sorting it, let me find the lowest numbers which I have here. So the lowest numbers which I have here is 1, okay. The first number is here, so let me remove it from here. The second lowest number is also 1 here, so let me write it here. This is again 1, okay. After it, the lowest number is 2, so removing it and writing it here, so this will be 2, okay. After it, I will have here 3, okay. So this will be 3 3, okay, 3 3, okay. So let me have 3 3, and after it the other number is 4, so 2 4s here, so let me cross them, so 2 4s here as well. So here I will have 4 4, okay. So 2 4s are crossed, and the after it we have 5, so the 5 is also crossed, and writing it here I will have 5, and the last number I have it is 8, so crossing it and writing it here. So this is what, this is 8. So these are all the numbers, so 1 2 3 4 5 6 7 8 9, so these are the 9 numbers, and in order to find the median of it, I have to do what, I have to find the mid value of it. So this is basically the mid value, and we can see that there are 4 values which are here. So let me use another color which is this red. So we can see that this is 3 and 4 values are at the left side of it, and there are also 4 values at the right side of it. So what is this? This 3 is basically the what, this is called the median value, okay. So this is the median of a value, and in this case we have the odd numbers, okay. So let me write them. So in values where we have odd numbers, so we will have in this the mid value, okay, mid value of sorted data. So suppose if we had also another number here, and let me have here also another 3. Okay, so we have here another 3, and writing that 3 here, what I will have now, the data I have is basically composed of the even numbers. So we can see that here 1 2 3 4 5 6 7 8 9 10. We have 10 numbers which are 1 1 2 3 3 4 4 5 8. So here, in order to find the mid value, what I have to do, I have to see that how many items are in the at the mid of it. So we can see here very clearly that these two numbers are in the middle. So in order to find the median of it, in this case where the numbers here are even, so what I have to do, I have to find the two mid values which are here. So I have to find them and I have to add them, and after adding them I have to divide it over 2. So this will be 6 divided by 2, and that would be 3 as well. So what is this? This is the median value of my data which is here. Okay, so I hope the concept of the median value is also clear now. Okay, so this is the concept of the median value. Similarly, suppose I have a certain shop in which the consumer has collected or found out some sizes which are mentioned here. So these sizes are 1 feet, 2 feet, 3 feet, 4 5, say 5 and 8 feet. So in order to order, or in order to see that what are the sizes which are more consumable in a certain city or in a certain area, how to order them. Okay, so there are different ways of ordering them. The first one is to see the mean of it. So I can see that 3.45 is not the size of a certain quantity, because this is 3.45 and we don't have here, and he cannot order 3.45. Similarly, we can see that 3 is also the whole number which can be a size, but in many scenarios it cannot be the size as well. So in that scenarios we have a concept which is called mode of a number. So in order to find the mode of a number, let me move down somehow. Okay, so in order to find the mode of a number, what I have to do, so mode of a data is what? Mode of a data is most repeated value or data point. So what is the most repeated data point? Here we can see that we have here 1. So 1 is repeated 2 times. Similarly, we can see that we have 2. So 2 is repeated 1 times. We have here 3. 3 is repeated, we can see 1 2 3 times. Okay, similarly here we have 4. So 4 is repeated 1 2 times. Similarly 5 is repeated 1 times, and also 8 which is repeated 1 times. Okay, so what is the value which is repeated mostly? So that is here 3. So 3 is what? 3 is the mode value. Okay, so for the data which we have. Okay, so mode of it is 3, and this is what, this is the answer. So in this lecture we have seen the conceptual overview of the mean, median and mode. Okay, so I hope all the quantities or all the concept which we had here are covered now. So these are basically the 3 quantities which are very important for the newbies to grasp the concept of the statistical analysis and analyzing the data which we have to infer some information from. So I hope all the concepts and all the relevant things related to the mean and median and mode are covered in this section. So if you have any question, you can ask me in the comment box. I will see you with some more interesting stuff in our upcoming video. Today I am going to talk about another very important characteristic of a data, and that is called the variance or standard deviation of a random variable. Okay, so previously we have seen that how can we find out the expected value, okay, expected value of a random variable or expected value of a data. Okay, Today we are going to talk about the variance and standard deviation, and also we are going to see that why do we need the standard deviation and variance. So in this video we will talk all about the necessity of the standard deviation and variance. Okay, so let's first talk about that why do we need expected values. So suppose we have a bunch of values, just like here we have two distributions. Okay, let me call them distribution A and distribution B. Okay, and this distribution A basically shows me the number of the matches a particular team has won in certain seasons. So let me have 6 seasons. So we have 0, 1, 2, 3, 4, 5, 6. Okay, similarly this is again 0, 1, 2, 3, 4, 5 and 6. Okay, so let's say the first team A has won season. It has won what? It has won some matches which are mentioned here. Similarly in other season it has won these matches, in third this, fourth this, fifth this, and in sixth season it has won this one. So in first season it has won 2 matches, in the second season it has won, let's say, 4 matches, in third it has won only 1 match, and this it has won 3 matches, in this it has won 5, and here it has also won 1 matches. Okay, so we have to find out that what are the average number of matches it has won. Okay, so in order to find out the average number of matches, what do we have to do? We have to add them all and then we have to divide it over this 6. So let us have this is x. Okay, x is the expected value. Similarly for team B, let us have team B has won these matches, these matches, these and these. Okay, so let me have this 2, 2, 2, 3, 2, 1. Okay, so let us have these are the number of matches a team has won. So sorry, this is 2. So we also have to find out the expected value or average number of matches this team has won, and that is why. So suppose team A has won in average 2 matches. Okay, on average this average score of it or expected value of it is 2. Similarly y is also 2. Let us have the value of y is also 2. Okay, so does it give us any information about the superiority of the team, that which team is better and which is not better? No, because it is saying that this is the expected value. Okay, this is what? This is the expected value of x and y, which is basically showing that both of average number of the matches won by each of the team is equal. Okay, so it is not giving me any information that which team has been consistent and which is not, because it can also be the beginner's luck as well. So this is not giving me any information. So that's why this expected value is also called moment, and this is the first moment of any distribution. Okay, so this is the first moment, as it is not going to tell me about the information of any spread. So therefore what do we need? We will need another moment, and that is called the second moment. Okay, and what is that? That is called the variance. Variance is the second moment. So what does a variance will show us? The variance will show us the average spread of our data. Okay, it is the average spread which a data has, and it is going to tell me about the average information. So suppose if I have this first random variable just like this one, okay, and a second random variable which has a distribution like this one, so which one is better? If the average values of both of them, let me call it mu1, mu2, if mu1 is equal to mu2, so which one is better? So clearly this one is better. Why? Because the spread is lower and it this distribution shows me the data is more consistent as compared to this one. Okay, so this one is better. So in order to find out in statistics, the spread of this is basically shown by the variance or standard deviation. Okay, so let us find out how to find them out, and in our next video we will talk about different techniques for finding the variance and standard deviation. We will talk about the mathematical formulation of them, and then we will talk about the particular case of a random variable in which we have to toss a coin 3 times and check the number of heads in each toss. Okay, so previously we have seen that this is the overall scenario, that why do we need the first moment, why do we need the second moment, and what is the first moment. First moment of the random variable is called the expected value, while the second moment is the variance. But the question here is that how to find them out. So let me move down somehow. Okay, so here let me see that how to find them out. So previously we have seen that the expected value of any random variable can be found out by multiplying each value of the random variable with the probability it has. Okay, so what is this? This is the expected value. Okay, or also the average value. Similarly, in order to find the variance, okay, so how can we find out the variance? In order to find out the variance, variance is represented by delta. Okay, and this is basically the delta square. In order to find it out, what do we have to do? I have to first find the expected value. Okay, and after finding out the expected value, we have to subtract it from the each data point which we will have here, then square it. Okay, and then I have to multiply it with the probability it has. Okay, so here by using this one, what we can do, we can find out the value of the variance, okay, which is given here. So this is what this is called a variance. Okay, apart from it, we can also see that this variance or sigma square is also equal to what? This is basically the value of x minus e of x and square of it. Okay, and this is what? This is called the variance. Okay, so if we have this formula, what we can do here is that, let me open it. So in order to open it, what we will have, as we can see that this is x minus ex, so we can also use here a minus b formulation, and here in order to apply it, what I will get, a square plus b square minus 2ab. Okay, so applying this formula here, what we will get, we will get here x square minus, so ex whole square, and similarly minus 2x e of x. Okay, this is the formula. According to the formula, when we have opened it, I will get this thing. Okay, so now in order to find out the expected value of it and separating them out, what I will get, separately applying this expected value, because this is a linear property, we will get ex square plus expected value of the expected value is again the expected value. So here we will get the ex square again, and here this expected value will be here, this expected value will remain the same, while this x will give me the expected value. So therefore here we will get expected value of x multiplied by the expected value of x. Let me remove it for more clarity. Multiplied by expected value of x. Okay, so these two will multiply together, and here I will get expected value of x square plus ex whole square and minus 2ex whole square. Okay, so let me move down somehow. What I will get here, I will get these will be subtracted from each other, and here we will get ex square minus Ex whole square, and this is what this is called sigma square. And in many places we can see that Ex is also denoted by a mu. So therefore replacing it here, what I will get here sigma square is equal to Ex square minus mu square, and that is the final outcome, or also called the variance of the random variable x. Okay, so what is this? This is called the variance of a random variable x. Okay, in order to find out the standard deviation, what we can do, in order to find the standard deviation, that is represented by st, and that is basically the square root of this variance. And in order to find it out, we have to just take the square root of the variance, and this will give me the standard deviation, and this is very easily calculated here. Okay, so these are the formulas which we have found out for finding out the variance. So we have two choices: either we can use the formula A or we can use formula B as well, and after them we can deploy or use this formula C. So whatever you want feasible, you can find them out, but for each of them, what do we have to do? We have to find out the value of this mu, because this is what, this is basically the mean value of our random variable. Okay, so I think it's enough for today, in which we have discussed the variance and standard deviation. In our previous video, we have talked about the variance and the formula which we have derived for the variance. Okay, this is for the variance and this is for the standard deviation, which has been mentioned here. So today let us have a scenario in which we have 3 coin tosses. Okay, 3 tosses of a coin of and here we have a fair coin, in such a way that this is a sequential experiment, because a coin has been tossed 3 times. Okay, and in our first video of this series, we have seen that the probability of heads, or the number of heads we have to find out, and the probability or the number of heads. Okay, or let me write it here, the number of heads in each toss is our random variable x. Okay, so in each toss we can have different number of heads, so the probability of that we have 0 heads is 1 by 8. Okay, the probability that we have the number of heads equal to 1, that is 3 by 8. The probability that the number of heads is 2 is 3 by 8. Okay, and similarly the probability that the number of heads are 3, that is again 1 by 8. Okay, so we have found it out, and this was the overall scenario. Okay, for 0 we have 1 by 8, for 1 I have 3 by 8, for 2 I have 3 by 8, and for 3 I have 1 by 8. Okay, we have also found out in our previous videos that the expected value of the number of heads here is what? That is 1.5. Okay, what today we have to find out? We have to find out the variance of this random variable. Okay, so we have here the variance, and the formula for the variance is the expected value of x square, okay, minus mu square, or this is also called mu, or expected value of x. Okay, do we have this value 1.5? Yes, we have. So there is nothing to find out about it, but we have to find out the value of x square. Okay, so let me call it formula A, and in order to find this value, what do we have to do? With the formula for it will be what? This will be the x square and the probability of x. Okay, so here applying it, what I will get for the first value, that is 0, we have to find the square of it and multiply it with the probability it has. Similarly, for the second value, that is 1, we have to take the square of it and multiply it with the value of the probability it has, and that is 3 by 8. Similarly, for the third one, we have 2 square multiplied by what? 3 by 8, which is the probability it has, which is given here. And for the last one, we have 3 square multiplied by 1 by 8. Okay, so now let me calculate it. It will be zeroed because now this is value 0. Similarly, here we will get 3 by 8. Okay, this will be 2 to 4, 4, 3, 12. Okay, that is 12 by 8, and here we will have 3, 3, 9. Okay, 9, 1, 9, so 9 by 8. Okay, so we will have here 9 by 8. So from it, what I will get? I will get 12 plus 9 plus 3, that is 24, and this will be 8, and that would be what? 3. Okay, so this is the value, which is 3, and this is what? This is basically the value or the expected value x square. Okay, so this was B, this was A. Okay, let me take this value which is calculated, or that is the value of Ex square, take it and put it here. Okay, in part A, and what I will get, let me move down. So what I will get here, in order to put it down here, we will get, sorry, let me use the white color here. So variance of it will be what? As in for mathematical equation A, we have here Ex square, so that is 3, and we have to subtract from it E of x, that is 1.5. so from it we will get what? That would be variance of it will be 3 minus 1.5 is 1.5. so that is what? That is delta square, and that is 1.5. so that is the answer of our question. In order to find out the standard deviation out of it, what do we have to do? We have to take the square root of this sigma, and that would be 1.5, and that is what? That is the answer for the standard deviation. Okay, so that's it for today, in which we have seen a numerical example which comprises of different values or different probabilities for the different number of heads